Welcome to the Precalculus student. We're gonna study this session, composite function. Previous session, we studied basic function and definition of function, how to evaluate. Now we combine more than two functions to make another function, but we mainly focus composition of two functions. What are you going to do this session? First, define a composite function, interpret its notation. Second, evaluate composite function. Third, decompose a function into two simpler functions. Third one is explain how composition differs from multiplication of function. Let's get started. How gonna define composite of two function? So let's thinking about box of function we studied in previous session. That's gonna be function g. Then we thinking about input of g. Then go through the box. Then come out the box. Then we have output g of x. That g of x is gonna be output, guys. Clearly see, x is input, go into the function of g, then come out to the box, we have output of g of x. Now, this output gonna be input of another function. So that's we have applied another function f to the g of x. This time, output of g of x gonna be input of function of f, right? Then input goes through the function of f. We have output of f g of x. That's how you define composite of two functions. Let's visualize it, guys. Here, input is x. You go through two functions, function of g, function of f, then you have output fg of x. We write this composite operation f dot g of x, that's the rotation of function. This one is x go to the g first, that's the output, go into the function of f g of x, output of f. We write this way. We defined this way. How gonna write? This one is f of g of x. Which one goes to the first? G first. Then you go to the second box of f. Let's have first example to evaluate composite of functions. I give two functions right here, guys. fx equal x squared plus 2x. G of x gonna be x minus 4. We wanna composite two function f of g of 1. So this one is clearly see, you evaluate g function first. So let's see have g of 1 first. Then I give the visualization of function g of x. So input, output, function of g. G of x is x minus 4. What is input of g? That's gonna be 1. Goes through this box. That meaning is g of 1, 1 minus 4, negative 3. Output gonna be negative 3. Now, g of 1 replaced with negative 3. Now you have f negative 3, right? So this negative 3 go to the another function of f. So f function is x squared plus 2x. This output of g go into the function of f. So input gonna be negative 3, goes through this box. So f negative 3, negative 3 squared, negative 3 times negative 3 is 9. 2 times negative 3 is negative 6. 9 minus 6 is 3. output gonna be 3. So what are gonna have this function f negative 3, we have output gonna be 3. That's how to evaluate composite function. Let's have another example. Now, this time we change the order. Previous slides, we start with the G. This time, let's start with F. So, let's start f of 1. What happened? F of 1, we evaluate f first, right? So, plug in the 1 into the function of f. 1 square plus 2 times 1, because fx equals x squared plus 2x. So 1 plus 2, that's the 3. What happened? G of 3 now. G of 3 now. 3 gonna be input of G. X gonna be replaced by 3. G of 3 gonna be 3 minus 4. That's the negative 1. So what happened here, guys? G of f of 1 is negative 1. Fg of 1 is 3. We got the previous slides. What do you see? This one is f first, go to the g second. This one is g first, f second. So order is really matter when you do composite two function. The value are different. So your conclusion is f of g of 1 is not same g of f of 1. So order is really matters in the composite of two function. You have to remember that which function you go through first when you do composite function. Guys, let's have another example to evaluate composite function. We have the same function, but evaluate different one. I want to use notation of composite function. So f dot circle of g of 0. That's the notation of composite function. How gonna evaluate this one? This rotation meaning is you start to G, close the input, then go to the f function. That's you're gonna do it, guys, right? So let's just start to 0 first. 0 go into the function of G. So what is output? G of 0 gonna be 0 minus 4. Negative 3, that's gonna be negative 4. Negative 4 go into the function of f. So that's gonna be negative 4. F negative 4 gonna be negative 4 squared plus 2 times negative 4. Negative 4 squared is negative 4. Negative 4 is 16. Minus 8 is 8. So output gonna be 8. So let's practice with this notation. F circle G of 0 meaning is F parentheses G of 0 parentheses. You're gonna inside first, that's you find it. G of 0 gonna be negative 4. G of 0 gonna be negative 4, which meaning is F of negative 4, then F negative 4 gonna be 8. That's how to evaluate composite function with composite notation. Let's have one more composite function to evaluate, guys. Here is same function, f of x, g of x. So this time we're gonna evaluate g of f of 0 without x. So what are you gonna do first, guys? Of this notation, we have to rewrite it. This notation meaning is composite function, but right here, g of f of 0 and 2 parentheses, we have to evaluate f of 0 first. Then we're going to evaluate g function later. So how going to evaluate f of 0? So f of 0 going to be, here is a function f of x, x squared plus 2x. X going to be replaced by 0. 0 squared plus 2 times 0 is 0. which meaning is f of 0 is 0. So f of 0 value gonna be 0. So you have g of 0. Now you have g of 0. You evaluate this function. So you're gonna have g of x, x minus 4. So x equals 0, you plug in the function of g. So that's gonna be 0 minus 4 equals negative 4. So now we have g of f of 0 is negative 4. Previous slides we had f of g of 0 is 8. Once again, order doesn't matter. F first, g first. We have different values. So f dot g of 0 is not same g of f. So order really matter for composition of function. You guys have remember that when you do composite two function. Let's do composite two function. This problem, we not gonna plug in any number. We find the function, okay? So I have two functions right here. F of x is 2x minus 6. G of x square root x minus 4. We want to find composite function of two functions. So we discussed order of composite function previous couple of slides. Now make sure when you see the notation of composite function, you have to know which function go to first. Just top is go to G first, close the input. Second is you go first F. F is close the input. So let's just start with top function. So this meaning is, this composite function meaning is F of G of x. So you start G of x. G of x is square root x minus 4. So F gonna be, gx gonna be square root x minus 4. This one gonna be replaced right here. Meaning is f of square root x minus 4. Now, square root x minus 4 replaced by x in the function. Guys, remember that how to evaluate function, right? So f, x is 2x minus 6. X will be replaced by square root x minus 4. So equal to square root x minus 4 minus 6. That's how to find composite of f of g. Now, second one is we're going to start with f. So in that case, let's rewrite this composite notation to find it. So g of f of x. So what is f of x? F of x, 2x minus 6, right? So f of x is 2x minus 6. That's go to the parentheses. So that's 2x minus 6. Now you have g of 2x minus 6. G of x is square root x minus 4. X will be replaced by 2x minus 6, which meaning is square root 2x minus 6 minus 4 minus 6 minus 4 is negative 10. So you have square root 2x minus 10. Can you see two composite function here? First one is start with g, second is f. That's the 2 square root x minus 4 minus 6. Second is you start f, go to the g, square root 2x minus 10. Again, this order is really matter, guys. Look at this. This cannot be same. This is different. So when you do composite two functions, make sure which go to first. Here is one application of a composite function. So everyone can read this application problem. Suppose oil spills from a tank into the Pacific Ocean. An area of split is a perfect circle. The radius of this oil slick increasing at the rate of 2 miles per hour. So one thing you notice this question is, guys, area depends on radius. Radius depends on time. So first question they ask, you think about express area of oil slick as your time of a function. So time of function, so I give the time t is in hours. So let's just start. Area is a circle, which meaning is area is a function of radius. So area of circle, that's the pi r square. But radius is increase at the rate of 2 miles per hour. So radius gonna be depends on time. So which meaning is every hours they increase by 2. So excuse me, radius gonna be 2t. Now a gonna be pi r square, r is 2 pi. So we can find area now, pi r square, r is depending on time. So r gonna be replaced by 2t. So pi r square, r is 2t square. 2t times 2t gonna be 2 times 2 is 4, t times t is t square. That's meaning pi 4t square. Let's put 4 is in front of pi. So you have 4 pi t square. So area is now depending on time. Now you have area as a function of time right now. They asking to calculate the area covered by the oil slick in 6 hours. What they give to you? 6 hours, that's the time. They give to you t value. T gonna be 6. Then you can calculate area, evaluate area. So A of t gonna be 6. You plug in the t equals 6. The meaning is 4 pi 6 square. 6 square is 36. 4 pi 36. The meaning is 4 times 36. That's the 144 pi square miles. That's the one good example of application. Now, we study how to composite two functions and evaluate composition of function. Now, we're thinking about decomposition of function. What do you mean by the decomposite of function? So here is the idea, guys. They give the h, some function, given function. You're going to find two simpler functions, f of g. Then we do the composite of f of g to the h of x. This process we're going to say composite of function. Do you understand, everyone? Given the function, we're going to find two simpler function f of g. When you composite two function f of g, that's going become to h of x. That's the process composition of two functions. So function as composition of two functions. Simple idea is to break down function into the two simpler functions. Let's have first example. Here is a given function h of x square root x minus 4. We're going to find the two simpler functions to make a composite of function to h of x. So, but remember that there is not one way to use composite of function, but it's up to you. You're gonna find what simpler functions gonna be. So let's just start with this example. Okay, so write a function as a composite of simpler function f of g. So we call this one is define the inner function, define an outer function. So what's gonna be inner function? What is outer function? Clearly, I'm gonna say inner function is inside the square root. That's I'm gonna call the inner function. That's I'm gonna put the g of x is x minus 4. When you decide the inner function, then you see the square root part, right? That's gonna be outer function f of x and square root of x. Simply, this is linear functions. This one is gonna be, guys, this one is a linear function. This is a square root function. Then let's try decomposite two functions that make original function h of x. Let's see. So f of g of x, f parentheses x minus 4, because g of x is x minus 4, x minus 4 go into the square root. Then you have square root x minus 4. That's exactly h of x. Now, can you see that? F of g of x gonna be h of x. You composite the function. So original function is h of x. Square root x minus 4. You find the inner function, outer function. Then when you composite f of g, you get the original function. Let's have one more example. I give the function h of x gonna be 1 over x plus 1. What is inner function? What is outer function, guys? Your guess might be wrong, but keep trying it. There's no one specific way doing this. Make sure you find the simpler function, okay? So here is outer function, inner function. Outer function gonna be what? Inner function gonna be what? So inner function is I gonna pick the bottom, x plus 1. That's the linear function. So g of x, x plus 1, f of x gonna be rational function 1 over x. General rule is outer function usually square root, rational, or square function, but not always, guys. Just very carefully see the function and you do the trial errors to find the inner and outer function. Then we're gonna check it by decomposition. So let's try it. F of g of x, f g of x is x plus 1, g of x is x plus 1, f is 1 of x, so we plug in x plus 1 into the f function. That's 1 of x plus 1. Now, can you see that? F of g gonna be h of x. You beautifully find two simpler function to decomposite the function. What do you learn this session, guys? First, you know how to evaluate the composite function. So when you say GF, guys, right? Second is, you understand order is really matter when you do composition. So don't mess up the order. Always the function close the input. That's the first, guys. That's you have to remember that. Third, we did decomposition break up function into simpler two functions. That's the process of decomposition.